Okay, so we're looking for two positive co-prime integers, m and n, such that the sum of the sine of 5k from 1 to 35 is equal to the tangent of m over n. So the thing is, if you know how to solve this problem, the solution actually becomes quite straightforward. But finding the solution is actually the hard part. So first I'm going to go over a few of my attempts at solving this problem, and then I'm going to go over a solution and then an alternate and, in my opinion, better solution. Now, I would like to remind you that timestamps are indeed an actual thing, and so if you do not care for my epic fails, then you may go and watch my actual solution. So first, let's make the question a little bit more clear. So on the left-hand side, we actually have the sine of 5 plus the sine of 10 plus the sine of 15 all the way to the sine of 5 times 35, which is equal to 175. Oh, and by the way, all of these angles are in degrees, not radians. And also, I noticed that the sine of 5 is equal to the sine of 175. And so I'm going to try and fold this series up. So my first option is the sine of x plus the sine of 180 minus x is equal to 2 times the sine of x. So then this gives me the sum of sine 5k times 2 plus the sine of 90, which is equal to 1. So then looking at this, we can then try sine of x plus sine of 90 minus x, but it just really doesn't get us anywhere, and so I'm going to try a second solution. So still following the same, like I'm looking for a telescoping series sort of lines, I'm going to try the sine of 90 minus x plus the sine of 90 plus x. Well, this then gives me the sine of 90 cosine x minus the cosine 90 sine x, and then we add the sine 90 cosine of x plus the cosine of 90 sine x. Now sine of 90 is equal to 1, so this is then equal to 2 times the cosine of x. And so now we can try doing a similar thing with 2 times the sum of the cosine of 5k, and then we add 1. But this also doesn't really get us anywhere, and although we might be able to telescope further, I really doubt it will be productive. And third, I tried combining equations 1 and 2, maybe by subtracting or adding these two equations together, but it really doesn't work out. And so now is a point when I know I probably have to look for a different solution. But I want to remind you is that if you have a sort of summation like this, with like the sine of 5, the sine of 175, one really useful strategy that often appears on contests like AIME is combining terms. It's just that in this case, that isn't the solution. And so the first solution involves the following identity. The sine of A times the sine of B is equal to 1 over 2 times the cosine of A minus B minus the cosine of A plus B. This can easily be shown by expanding these terms. And so now we can take this summation, k equals 1, 35, the sine of 5k. So we can multiply this by the sine of 5 over the sine of 5. This is then equal to the sum of 1 over 2 times the cosine of 5k minus 5 minus the cosine of 5k plus 5. Now all this being multiplied by 1 over the sine of 5. So now this turns into 1 over 2 times the cosine of 0 minus the cosine of 10 plus the cosine of 5 minus the cosine of 20, all the way on to minus the cosine of 180, all of this being divided by the sine of 5. And so as I mentioned earlier, this is a telescoping series. And so all we're left with at the end is 1 over 2 times the cosine of 0 plus the cosine of 5 minus the cosine of 175 minus the cosine of 180, all over the sine of 5. So now using the fact that the cosine of 0 is equal to 1 and the cosine of 180 is equal to negative 1, we can then simplify all of these terms to get 1 plus the cosine of 5 over the sine of 5. This then rearranges into 1 minus the cosine of 175 over the sine of 175. Since the cosine of 180 minus x is equal to the negative cosine of x, and also since the sine of 180 minus x is equal to the sine of x. And now I want to show and prove an identity. So I want to show that the tangent of x is equal to 1 minus the cosine of 2x over the sine of 2x. So using our double angle formulas, we get that the tangent of x is equal to 1 minus the cosine squared of x plus the sine squared of x over 2 times the sine of x cosine of x. So now, using our Pythagorean identity, the cosine squared of x plus the sine squared of x is equal to 1, we get that the tangent of x is equal to the cosine squared of x plus the sine squared of x minus the cosine squared of x plus the sine squared of x over 2 sine x cosine x. Then the tangent of x is equal to 2 times the sine squared of x over 2 times the sine x cosine of x, which is finally equal to the sine of x over the cosine of x, which is by definition equal to the tangent of x, and so we have proven this identity. And so now, substituting this in, we get a final answer of 175 over 2, or 175 plus 2, which is m plus n, which is equal to 177, and that is our answer. Now, the problem I have with this solution is that this is not a really well-known identity, and neither is this. So if you don't know these two identities beforehand, then it would be very hard to solve this problem. So now I'm going to show you one more solution. So this solution is a solution that involves complex numbers and Euler's formula. So we know that e to the power of ix is equal to the cosine of x plus I times the sine of x. And so the imaginary part of e to the power of ix is equal to the sine of x, and the real part of e to the power of ix is equal to the cosine of x. So notice that the sine of x is equal to the imaginary part of e to the power of ix. And so now we can rewrite our summation as the sum of the imaginary parts of e to the power of 5ki. So this is all equal to e to the power of 5i times 1 minus e to the power of 175i all over 1 minus e to the power of 5i. And also taking the imaginary part. So making substitutions, we get that this is equal to the imaginary part of 2 times the cosine of 5 plus 2i times the sine of 5. Now all this is divided by 1 minus the cosine of 5 minus I times the sine of 5. So now we can multiply both sides by 1 minus the cosine of 5 plus I times the sine of 5. And then taking imaginary parts, we get 2 times the sine of 5 over 2 minus 2 cosine of 5. This then simplifies to the sine of 5 over 1 minus the cosine of 5. And so now we can change the sine of 5 to the sine of 175, and the cosine of 5 to be equal to the negative cosine of 175. So we have 1 plus the cosine of 175. Now applying the tangent half angle formula, we get that this is equal to the tangent of 175 over 2. 175 plus 2 is equal to 177, and so we are also done. Now, in my opinion, this solution is much better because it's a lot more straightforward and it's a lot easier to find out without knowing all these really niche, not really ever used trig identities. However, of course, as long as you get an answer of 177, whatever floats your boat, whatever you prefer, it's probably just okay. Alright, thanks for watching. Hopefully you enjoyed, and hopefully I'll see you next time.